Okay, let's go here first. Hello. Yeah, so I just want to put my picture up so that'll trigger that you're actually watching and know that this has started. First, I want to go back to this picture. So after it's OpenAI Dev Day, whatever that's called. Yeah. This is on right now. And so I watched the keynote yesterday by Sam Altman, whatever. And so it was enough to get me to sign back up for ChatGPT Pro. But then I went and I asked it to make a thumbnail for this video. And I was actually quite impressed. I mean, now you can just like ask it in the chat and you don't have to specifically go to Dolly, which was kind of nice. Their text has definitely gotten better, but it's just so mildly off. Like tutorial with 2 eyes, has got this weird like bee-like thing, and WASM. I just thought it was great. Just, yeah. Otherwise, it's such a great stock photo. Anyways, that's just a little starting detour for us. Okay, so why am I showing this? We're talking about WebAssembly. Great question. I wanted to start with, I was out for a walk yesterday and I was like, okay, I'm going to talk about WebAssembly, but I'm still, I won't say struggling, because I'm interested to watch this video in several years to see how this all plays out, but in a lot of ways I'm not super convinced on WebAssembly, but that probably falls more on the server side usage of it. In the browser, I can see, and I actually currently use one very useful thing that WebAssembly enables, and it's in this app, Kaizen. And so let's go over that first, and then I'll kind of like reverse that through a little bit of like what a WebAssembly is, but like what it enables, how and why. So this is kind of, it's a music platform that we're working on. I won't go into that too much, but this is a new song that I saw go up, and we have this option to create a post. And I was pretty keen to have this, particularly for myself, because I find it very difficult to go and make little things for your Instagram or TikTok or whatever. And so I wanted a way, I just made a song, and then I wanted it to just create the reel for me. And so let me open up the network tab as well. I prefer that on the bottom, thank you very much. And let's just clear out everything. Cool. So we'll get to see a little bit what goes on here. 15 seconds should be fine. So create. I haven't even listened to this song yet, so you're getting free advertising here, Louis maybe. So that's a start, and then it's instantly just like, hey, would you like to save this? And it does. And so now I have that video downloaded as an MP4 that I could go and listen to or share on social media, which is actually how it's intended to be used. Here we go. This is where you start to see kind of the WebAssembly come into play. So I think it even logs it out. Yeah, great. So kind of technically what's happening here is you see when I hit create, it actually, and let's just do that again, and I can probably cancel in the middle. You'll see it actually start rendering it. This is just a canvas. No, download it again. I think even here, yeah, even here it's a canvas. And so when it starts animating it, it is a live canvas that's like being drawn every single frame. And then what's happening is on, we're using a I always forget what it is, media streamer. There's some browser, let me, media stream, record, canvas, something. That should do it. So you can do a canvas capture stream, and then media recorder, that's the word I'm looking for. So we do that. But there's a couple problems that come into the mix, which is that records at whatever the browser happens to record. With Chrome, I think this is accurate across all platforms, you pretty much can only record to WebM. And if you've ever used basically anything else, like the browser loves WebM, but basically no one else does. And so you can't directly upload a WebM to these platforms. And so the first iteration of this, we had it, and I was like, okay, cool, like we're done. Like we just record a media recorder, bam, 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 it's great. But then all of a sudden, it would finish the thing, it would spit out a WebM file, and then I'd go to upload it to Instagram, and it's gonna be like, this file is not supported. And I was like, great. And so then I have FFmpeg, real quick, installed on my machine, and so I'd do something like this. Not quite the thing, but this would be whatever the WebM, and you'd convert it to the other thing. But then there was like even more problems with this. Like A, I needed to have that installed. B, I need to remember this command. Then I need to do it, and then the actual like however long your video is, converting that video is gonna take. Sometimes it's faster, but like it's basically like another set of listening to that whole thing in order to get your final video. And so finally be like, okay, great, I have my MP4, and then I can upload it. And so then I started doing some investigation, because I was like, I mean, one thing I found was that the Safari actually allows you to media record directly to MP4. So that was kind of a starting place. But there was still a problem because the raw recording it took was far too large. And so we essentially needed to like reprocess it to compress it a little bit heavier. And so that's when I started looking at, let's see if I can open both of these. FFmpeg WASM. Pure WebAssembly JavaScript port of FFmpeg and everything, blah, 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 stream range are the values. Okay, so now we can actually get into why WebAssembly. And again, I'm starting here because this specifically FFmpeg WASM, but it also, I could see how it expands from here in terms of other use cases, is the best use case I can see right now. I'm gonna be dramatic about it. And so FFmpeg is this, I'm sure it's written in C, I don't know for sure, but probably. Will that even tell me here? Blah, 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 blah. I don't know, but I'm pretty sure it's written in C. And so obviously you can't use that in the browser, but essentially WebAssembly allows you to compile that C program into something that the browser can actually run and execute. And the reason this is useful is a couple things. So I think probably more important is that, which one was I going to pick? There's two. There's performance, but there's also not having to rewrite. And I think the not having to rewrite is probably more important. Whereas like FFmpeg supports like all kinds of different codecs and blah, 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 blah. And there's all kinds of weird intricacies related to that. And then these update over time, there's new ones added. And so FFmpeg in itself, I don't actually know of another program that even does that. So that alone tells you that the amount that they have inside of FFmpeg is enormous. And so if somebody were to go, okay, cool, I'm going to rewrite FFmpeg in JavaScript and then also maintain that over time as things go. Maybe it would work, but at the end of the day, most use cases of FFmpeg and that kind of video processing, you need the raw speed of C. And so it makes way more sense to write it there, optimize it there, make it all perfect, make sure it supports everything, yada, yada, yada. And so then being able to compile C to WebAssembly just allows us to take everything that we've already built and reuse it inside the browser. And then let me go to the WASM page for this one. Yeah. What do they? Yeah. So they start with efficient and fast. Safe. We'll get into that later. So this is their actual first purported benefit, which also isn't necessarily wrong. Like the WASM version of this is probably faster than the JavaScript version if it were to exist. I just don't think in this case the JavaScript version ever would have existed. Yeah. A little bit of a tangent here though is that I really feel like the browser should be providing much better access to this, because a browser already does know how to deal with all of these different codecs and all that jazz. And there's a little bit happening there. But the only one that comes to mind, and this will maybe take me, yeah. So there's a web codecs API, but it seems very, like here, there's currently no API for demuxing media containers. You need to implement it on your own or use third-party libraries, and it's just like very quickly there's no real use to the API because you have to use something else in order to make it useful. Whereas I think it could be interesting and probably faster than FFmpeg WASM if I could just use the browser itself and say, hey, here's the frames I would like to write to a container. Can you put them in? Also, here's the audio, blah, 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 blah. And like to some degree you can, and maybe some of this is that I just don't know exactly what you can do, but the resources on it are quite small. So that's a mild detour aside. So let's get back to this and here. So now if we take a look at the network tab, you'll see this guy, WASM, and the worker. And these don't get loaded until you actually start to use the thing. And the reason you can see is that this is huge. It's 8.5 megabytes. But that's essentially because it's bringing in the entire FFmpeg program. And with some exceptions, and I did run into some of these, like some functionality doesn't work or isn't the same, but overall you can kind of use the same thing. So then here is some of the logging that it spits out. So here you can see that it wrote the WebM file. So basically we took that first recording, which did spit out a WebM file, and then there's this FS, and maybe this is better described somewhere in here. Maybe getting started. This feels new from the last time I used it. Oh, look at that. That's exactly what we do. This should make it a little bit easier then. Core URL, yeah. Great, so we can just walk through their code because I don't need to rewrite this. So on load, this loads it from a CDN, which I don't think we currently do, but we probably should. And then you load the core.js and then also the WASM. And then the transcode, get it, you write file. So this deals with, WebAssembly has this concept, I don't know it super well yet, but of essentially a file system, but that file system only exists within the context of WebAssembly. And so this is very similar to what we're doing, except here they're using an external file, whereas ours is one like a buffer we essentially pass to it. And so then we write that in as input.webm, and then you do ffmpeg exec, and then this is basically what you would do on the command line. So ffmpeg-i, that's your input, and then this is the output that you want. And then you just await it, and then this does all the processing, and so that's where you start to see all of these logs, blah, 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 blah. And I did it twice, so now there's two right here. So if I end, it means that it wrote it, and then here it reads the file output.mp4. And if we go back here, they do something a little bit different. So they put that now written MP4 into the source of their video, and you could then theoretically play it. Really, like, it would be somewhat difficult to know that this worked, but you could basically then just download it and get access to it. Oh, interesting. Can I test this? Let's find out. They say 31 megabytes. That's not how large I thought it was. Oh, 63.7. Does this expand that large? Okay, yeah. That's interesting. So that kind of shows how much compression is possible off of the WebAssembly stuff. Okay, and then I hit this guy. And then they're kind of spitting out how fast it's taking. And then, voila, you have MP4. Whoa, interesting. Multi-threaded. Does this do the same thing? And if so, can we see how much faster it is? All right, okay, I'm learning things here. Oh no, just tried to send an email. Okay. Oh wow. Oh wow. Okay. That might be already what I have. Oh yeah. So this now pulls in the worker, which if you have a look at what we're already doing, we also pull in the worker, which should mean, did they specify anything else to make it magic? Not really. Okay, what else they say, and then we'll probably move on with the progress, yada. Into segments of duration, no, display text on video. That's fun. Interlace two videos. Cool. I haven't seen this, so I'm just gonna poke around a little bit. Excuse me using this time to learn something. So here's blah blah blah. Filed from C source code. There it is. Oh, they even give you a nice little comparison. Wow, that's actually quite interesting and surprising. 10-second clip. That just feels not correct, though. They're essentially saying that it took 5.1 seconds for this, and then 60 seconds in the browser. Like, that's not how long it took my previous one. So what are they using? A 2.4 gigahertz. I wonder if that's either they haven't updated this, or the Mac does that significantly better. But if we go back, oh no, too far. Here, I mean, first we load it, and that's fine. This was done like nearly instantly, like 1, Like that's 2-3 seconds max, which is faster than what they've listed this as. Huh. Okay, I might explore that later on my own time. Oh, each command is executed 5 times. There, now we're talking, okay. But even still, 5 times 3 would be 15 seconds. So, interesting. That could be a fun test to compare now. Like either they're behind or it's just their environment that's different. Okay, so we started with kind of like an actual use case for WebAssembly. I think this, in my opinion, did a good enough job of showcasing how to use it in the browser. So do we do it? I think we do. Okay, fine. Let's just do one of these. I might already have a WASM folder. Yeah, but did I do a dumb thing? I did, yeah. We can just get rid of that. Okay, so they are trying to use React, and I would prefer not to, so let's see if we can do this without. It's also funny that they just, they don't even specify that this is React. Use ESM in the base URL instead of UMD. Interesting, okay. What I'm going to try to do is see if we can keep this all in one place. So we can also, we'll just do the same thing that they're doing to start. Message, I don't care about that. Even this, we'll just do that on load, I think. Or on this even. Okay, so then, and we need this to happen after everything is loaded, so we're just gonna throw it here. Now, the fun-ish thing. Why have they commented these out? That makes... Oh, is it because they're doing this base URL? No. You cannot import from a CDN like packages are going to be downloaded and hosted from your server most of the time. Okay, so let's listen to them. Oh, you know what? Sorry. Wrong screen. I forgot. Sometimes I forget. Okay. So now we've got that, which really means we're going to need a separate. Let's just put it here. And then I'm still going to try to do this without React, and we'll see how it goes. Did you actually use fetch file? I don't understand why they put the comments here. New WebAssembly page. build because there's no way I trust Bun to have figured this one out. Dear. Should just create it. See that. Okay, and then we'll throw that guy in there, and then we'll change this to be index.js, and this will be defer, so it loads after the other stuff, and slash for good measure. And I mean, the fact that that didn't really do anything, yeah, that didn't import shit, so we probably need bundle, is that what it is? Oh, look at that, look at that. Okay, yeah, so that brought it in, great. Okay, and they're essentially saying I can do this, so let's find out. And then we're gonna use this weird reference stuff. Sure. Log, don't care about that. Sure, we can log it. This. And we need to wrap all of that in a same function. Okay. That. Blob URL is not defined. Failed to construct URL, we're getting closer. Slash worker. Let's just see, I'm probably missing something from. Which one did I copy to? Blah blah, yeah. We'll go with it and let's see what happens. So write file, read file, video, easy, easy, easy. It's never easy. And then we would like the transcode button, and that's going to be transcode. Won't do any of this. Can we do that one? Sure. So on click, oh gosh, click, we'll do everything. Oops. It's gonna be sync. What do you think? It's gonna work? Probably not. Well, let's find out. Let me just tidy this up before I forget. Okay, and loaded that. Still got that error, but let's see what happens. Okay, ffmpeg.load. So it's going to be these guys. That's the problem. Base URL. Package. Oh, let's try that. Always read the instructions. That seems maybe better. Nope, that doesn't seem better. Worker. JS. There's always something. Okay, what I would maybe like to try is I don't think we need to specify this, and then it should attempt to load from my own machine. And let us see if that's true. And then okay, it's just the same error. Alrighty, okay. Sounds kind of like it. That's not quite right. Giving core path and rewrite blah 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 blah. Build target to ES20. Transformation target. Just target. Okay. I have no idea if that's actually the case, but this is the fun stuff you get when you deal with something relatively new, even though I would argue it shouldn't still be new at this point. Okay, that's not good enough. That's fine, could have gone over that. Sends message. I mean, maybe this helps explain what the problem is in the first place. WebAssembly exec file system sends message back to the JavaScript main thread, web worker thread. I always see this and I read libass. Mapping. Okay, so this looks more familiar, so this must be what I was using. 0.12 plus. Surely somewhere there is something. Okay, not quite. We'll get there. I know it. I feel like it's looking for this. So how do I... That's me. This doesn't use it, does it? Oh, it does. Am I gonna find the answer in my own one? I'm curious. Yeah, so the old links they've already ruined. Okay, but we did use... This is literally my own article. Can you get out of here? Go into my own account to freaking access that. Let's see here. So that's same. Oh, interesting. Okay, that might be my problem, and I might have just saved my current self a lot of time because I totally forgot that. So surely you... Oh, it's still put at the top level. That's fine. Two, of course. Okay, and okay, same problem. Great. Good start. Okay, that's interesting. Let's try two things. So first, we'll remove this altogether. I'm curious what that makes it look for. Okay, let's bring it back. I think it's wanting the worker, even though this page said it didn't necessarily need it. Okay, this is my hope. Okay, that's correct. Can I think there's a watch version. Something like that, maybe. There we go. Okay. Okay, that's progress. FFmpeg core worker JS not found. Oh, because I apparently did multi-threaded one, which we might as well. Let's just go big or go home. like that means that it's something's not right. Okay, let us try downgrading, because that one I know worked, and we can figure out the problems a different time. Yes, this is how dealing with anything WebAssembly feels. 100%. Get started, blah, 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 blah. What else do I want? What am I here for? Releases. So I'm looking for the last 0.1, 0.11, 0.6. This one probably doesn't exist, of course. Let's try something like that. Of course. If we come here, I maybe only needed one of them in the first place. Yeah. Change this to be that. This guy. Okay, so all of this is different. Let's just get it to load first. This isn't really where I expect it to be, but here we are. Let's remove that guy. There we go. And now, perfect. It can actually load itself. Interesting. So that's a thing that I'll need to figure out. Strange. But now we should still be able to use a fairly similar example. I'm actually kind of glad now that I tried this, because that was most of my like. There are these docs that basically tell you exactly what to do, and you'll still find that it doesn't work. So ain't that fun? I wonder. Like, what they probably should have is docs to their old 0.11 version as well, but they don't. So just the fun of using something brand new. Okay, so let's take a look here now. And in my example, I was uploading a new file, but I don't think we need to do that. We can instead kind of like write file, blah, 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 await fetch file. And the problem is that fetch file is part of this, but there's no reason we can't use that. Let's find out. Okay, let's bring this in now and see if it complains. Nope, none of those. this, but in the old style, which is going to be this. Name of the file, so and then maybe that. And I wouldn't be shocked if this still has a problem. Okay, look at that. Great. So that gives us writing it, and then in my case I was dealing with audio, but it's kind of same. So then read file. Okay, we're close. We are finally close. So we do this. That's changed. I mean, this is a nice little conversion guide, if anything. Not that I care, but what did they choose for their put.mp4? Data buffer. Did we do it? Check if path exists. That's totally the wrong one. So input is web, and nope. There we go. Okay. Did convert it. Failed one more time. Check file exists. Oy, okay. That's because it's reactified. And okay. Interesting that we got a picture. What's wrong with my video? Type video MP4. Do I need to add maybe controls? There we go. Okay. Whew. Only 45 minutes in. And we're still not even on the latest one. And so I'm curious. Let's just do a time load for one. So see how long it takes to bring it in. And then what I want to do is how long it takes to convert. That should be enough there. It's going to get swallowed inside here. Oh yeah, so 2 seconds to convert. And 1 second to load. Which does that correspond to? Oops. Yeah, pretty much. So if it took 850 milliseconds just to bring this guy in, we did have a little bit of parsing to do. So that's, you got a second to load the library and then 2 seconds to do the thing. But if you're doing lots with it, you would just load it once. What I'm kind of often surprised by is why this doesn't get cached. I don't know if it's because it's too large or what, but logically you would want to cache this so that you're not downloading it every single time. But who am I? I don't know everything. Okay. So that was a long bit about the browser side of things. Do I want to stop there with the browser? Yeah. And then let's change gears and take a look at the server side of things. shouldn't need that anymore. And where do we begin with this? So, use case. Let's just start a new, dear, what do I want to call this? Server WASM? Sure. So let's go back to this home page here. Again, they're like efficient, fast, safe. I mean, I can see it on the browser side as well, but I think the interesting thing that's being explored is this like JavaScript virtual machine side of things. And so currently what often happens is people will put their Node.js thing inside of a Docker container, which allows them to then spin up multiple environments within a single like other virtual machine. But those are huge because they're essentially running an entire operating system. You can get them a little bit smaller by using a small operating system, but at the end of the day, you're kind of stuck with, okay, a minimum, some operating system needs to exist. But with WASM, I'm going to go through, hopefully, an example. And I'd like to start with a Rust one, but I want a correct. I want the right one. Nope, not quite. Where did I find? So I'm still getting the lay of the lands with some of this stuff, but there are essentially different run times to then run WebAssembly, and I think a decent analogy for this is it's like, okay, cool, you can write JavaScript for your server, but the runtime itself in most cases is Node. Nowadays you've got Node, you've got Bun, you've got Deno. I'm sure there's others I'm not even thinking about. WebAssembly is basically in the same realm of things. As I'm starting to pick up, WASM time seems to be, I don't know if I can say the official one, but this Bytecode Alliance seems to be kind of like a standards body for this, and they've got pretty much most of the big players involved, so I think that's what I would trust for now. Cool, we will just go. They seem to have a much quicker getting started. So I've already done this, I have it installed, but you would need to do that. And let us do a cargo init here. Yeah, I can. Okay. You probably already do hello world. Great. And then this already should have been done for me. I think this is what you do with this cargo, but we're just going to follow the instructions. Cool. So that compiles it. You can see this new WASM thing here, and we do a WASM time main.wasm hello world. The nice thing here is, I mean, that's still almost larger than I would expected, but that's 2.1 megabytes. And that's it. There doesn't need to, like, you need WASM time, but you could just have a single WASM time on your server, and then you could have however many different WebAssembly files that you need. There's also, let me see, time compile WASM. compile. I think WASM Edge comes with WASM time. It's a little bit confusing at first, and by a little bit I mean a lot of bit. But I also have WASM time Edge, and then I want to say you can say compile this guy. Yeah, okay. Main.wasm, main aot.wasm. And this essentially just generates a more efficient, I'm going to call it binary. Whether that's the correct term or not is debatable. So in this case, that pretty much makes sense because there's some basic amount of WASM that you need in order to like actually run. Though, if you really ask me, why does there need to be like, we already have a runtime, and so surely the runtime could handle most of this stuff. Like in this case, our actual code is what, it's like 44 bytes. And if we're dealing with a runtime, I don't understand why the WASM ends up being 2 megabytes. Again, I'm no expert, but I feel like a lot of what's in here could probably just be dealt with the runtime. Somebody would tell me how wrong that is, but that's my initial thought. Okay, so maybe start analytics. Don't know if that's what I want. Oh, we're closer. I do want to show a server in it. Okay, maybe those are the instructions I wanted. Server WASM, blah, blah, blah. Rest examples for WASM Edge. This, I think, is the one that I wanted to. So high performance HTTP service with a hyper WASI crate. Great. So this should be, yeah. Great. Okay. Let us see how I do. It has been a while. Okay, yeah. And then just take a quick peek at this. Hyper, great. So main, connect to port 8080. And then we just listen to accepts, spawn a task for each one, HTTP serve connection. An error service function is echo. Great, yeah. So then match on the method and the path. So forget this. Blah, 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 posting. Echo request into body. Okay, echo reversed, and then a 404 for everything else. So we should be able to first do whatever. Oh god, is the cargo run? Yeah, okay. You know what? I was just about to say this should fail, I think, because we're using this, the WASI versions of these. So once we've done this, we have to use WASM, but, and let's see. Of course, 14, so I think we can just change the version of this. see if we can get this to work in regular Rust first. Seems like maybe. Cool. So that's it working. Let me comment those out. Not. Oops. Is that how you do a comment in here? We're gonna find out. And then back to WASM, back to version 15. And something here. So it should fail again. Yeah, okay. And how do you tell me to build this? So we're using the target WASM, which will compile it to WASM instead of an actual binary. Let's just kill these guys. And then you'll see this new target in here, and we get this final guy. So the first question that I for some reason have an obsession with is, okay, 3.3 megabytes. And then suppose we can just run a WASM edge. Let's see how that goes. WASM edge, target, blah, 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 release. There we go. And there you have it. That's running on WASM edge. What I'm eternally curious about, do I still have? Did I install it globally correctly? No. Here. That's for some reason installing it this way just never works for me, but we're gonna try it again. So you'd think once it's done that would actually happen, but I don't. So what did I have to do last time? I think I just went to releases and Darwin, yep. Okay, second. Security. I hate this max setting, and I wish there was a global way to turn it off, or just a nice way where you could not have to go and find it. Privacy and security. Nope, still the wrong one. Allow anyway. Okay. Just do it. Thank you. Cool, so we broke it. Pointer to metadata being freed. We got 18 responses and then it blew up. Connection reset up here. Which I think means we might not be able to get a good answer for this one. Let's check. Is it the WASM or is it just the way the server is written? Okay, that seems to successfully be responding. Okay, and then 15,000 requests per second. What I wanted to see is what the performance difference is. The problem is apparently it can't survive. Okay, that's fine. Maybe I'll figure that out another time. Okay, so let's do a quick comparison. So if we were to take I spelled that wrong. The Docker containerized version of this. So a Rust Alpine, I think. Do we want to build it, or can we just copy it over? Do that. Copy source. We'll just do the cheapest one. I don't do it perfectly. And then I want run, or do I want build? Let's do build. Yeah, and then I'll fix it after. Okay, so do a docker build -t server this guy. So we just copied the source, that's all. Target, that helps very vaguely, I'm sure. Cargo build release did not, blah blah blah. Couldn't find cargo Tom. Well, yeah, that makes sense. Now what? No targets specified in the manifest. Failed to parse manifest. Fix that. And then one more time. Yep. Okay. This should end up being quite large. There's a little bit we could optimize, but let's have a look. No. Come on. All right. This is because Alpine doesn't do blah blah blah, so sure. What do you say? Fifth and final Docker file. Okay, so even here they've kind of done some of the work for me here. Where they like their first image was 2.4 gigabytes, so definitely the 3 megabytes that we're dealing with is way better. Binary Why does it seem like you didn't actually put the 5th Docker file? So we're using Slim Buster, we're 642. I know I have found this here. This is what I'm looking for. Okay. So bring this back. So here now the builder is a larger one, whatever. Interesting. Oh, that's funny. This isn't even using the code. That's fine though. I think that'll still give a picture of what I'm looking at. Or not. There we go. Interesting. 3.36 megabytes. Docker run. What do we call this? Server, I guess. Oh, no such file or directory. Great. Do I want to get into this? Maybe not. Let's not say we did. So hypothetically this should be the roughly correct size, and it's just copying over an executable. So if we were to do that for ourselves as well, it would just be this guy, which is 2.3 megabytes. So even there on size, like, yes, you have to like work your Docker file a little bit, but I guess this kind of like introduces the question and debate that I have, which is we have Docker solving a similar problem. And I went to DockerCon kind of like searching for this answer, and I didn't really get it, which is not super surprising considering it's DockerCon and they need to promote Docker. But I think like there's some argument that WebAssembly could be a replacement for Docker altogether. But then there's also the fact that all of our tooling has already been built around containers. And so essentially what Docker did is it allowed you to just run WebAssembly inside of Docker, which we could kind of get into. Let's try. WASM Docker. Platform WASI, blah, blah, blah. So this will be more context, I think. Yes, that's fine. And then I don't know though, and their documentation on this is, oof. There we go, that's good enough. So still from scratch, and then we copy from, we're just gonna copy from our local thing instead of having a whole build. So instead of that, copy target release and that's already wrong. Should be target WASM 32.waz release. So WASM.wasm. Voila. Okay, so then surely this won't work, but we're gonna try it. Of course, just maybe context is not allowed. Maybe it is built, yeah. Path. You can tell I really know. Got the cache key. Okay, we're getting close. Target WASM 32.waz release server-wasm not found. And why not? Pretty sure that does exist there, bud. Oh, do I need to make a whole stinking build? Oh, maybe that's it. Build X build. -T. Okay, let's try it. Oh, I'm a silly goober. Okay. That could have been a lot easier, couldn't it now? So then what's the run? Oh, I guess just that, hey? Look at that. She's running. Oh, I need to explode it. this by now. Yeah, there we go. Okay. Cool. I guess we never tried this. There you go. I bet you it still blows up though. Oh, maybe not. Okay. But this is exactly, this is so much slower. We've got like the WASM layer slowing it down, and then we've got the Docker layer slowing it down. I still don't fully understand why if I do, can I do WASM time actually? No, so WASM edge has got the magic socket stuff, I guess. Again. Okay. Maybe we just had a random error last time. Sweet. Okay, we can compare our numbers. So 5887 is technically a little bit faster inside the Docker container, but like a world away from what the actual raw one was doing, which I wonder, can I still do it even though it's listed wrong? Let's find out. It's gonna fail. It's already built, bro. So we're at 6,000 requests per second, and I think this is gonna shoot back up to 100,000. So 6% of the performance, which is kind of like, especially if I could use my old Docker file to put the Rust thing inside of it, which, oh yeah, we're here, we're gonna do that, we're gonna go back. Duplicate you. I can even do the large version, that's fine. That's my guess. I think it's gonna be almost half as slow. Right. What did you say, Buster Slim? What is your problem? This version of cargo is older. 7.3. Oh, I'm also on a Mac. This is even more unfair. I'm still gonna get the numbers though, just to show. Also, compiling your Rust in a Docker container is obnoxious. Now, what's your problem? Is that just a random error, or are we just gonna keep getting that? Failed to read a Docker file. What on earth? I have no words. Just an unenjoyable experience with Docker at nearly all times. And now Rust has to rebuild everything again, which makes little sense. Cannot compile send read-only file system. Okay, let's just do the whole big boy. I don't know. What can we even just do? Let's try that. That didn't close Docker, but it decided. Great. Docker has just oh, I'm out of space. Oh, okay. Ain't that funny? Okay, well, I would need to open Docker to clean up space. So that's great. But let's try to clean up some garbage. I have 3.6 gigabytes left. Friends don't let friends use Docker. We could probably just delete all of our other Docker images. It's not as much space as I thought it would be. And this is probably the last thing I actually want to do, so we'll just cap it at that once this has gone through. I lost my fun little circle. When did that happen? Oh, because I deleted the file that was the mask. Ain't that funny. Okay, so we called it rest server, and rest server. Now it's listening, except it's not because it's not. We gotta do dash p. Okay, and then. That's what I cleaned up to make space, and obviously that was not quite right. And again, oh my. So unenjoyable. Where privacy and security? Oh my god. Okay. A long time just for this dumb answer. What? So that's less than half as good, but still significantly better than the WebAssembly. So I think like the conclusion that I've drawn so far, and I'm looking for a more solid answer, is why would I use WebAssembly? As blunt as that question is, at least I'm talking as a containerization option server side. Now, like, I can envision that there's all kinds of ways to make improvements. But if like fast and efficient is the way it's being touted, like that should have been the default. It's not like, oh, we were fast and efficient, but here we are shit, and then we make it fast and efficient. If you're saying it's fast and efficient, then that's just what it should be by default. I guess in some fairness, what I'm understanding and starting to see is that like WASM is kind of like separate from this whole WASE. So this is whatever modules. This focuses on security and portability. Yeah, this does not really describe that super well, but as I understand it, it's kind of the WASE that, again, gives you an interface to the system itself. And so maybe that's where like the actual WASM side of code is reasonably decent, but the accessing system dependencies, maybe that's just a little bit slower. And by a little bit, I mean a lot of it. Yeah, I would be shocked if I didn't watch this long, but this was kind of nice for me to see how long it would take to kind of walk through this. We started with the browser side of it, which, again, I started with that because to me there's clear tangible value to that. Using FFmpeg WASM in your web application, there's all kinds of things you could do right now, today, and it brings you value. I'm sure you could come up with certain use cases of like, oh, I'm writing high performance stuff for my web app. I would be shocked if many people actually correctly have those. Figma's probably the most touted example of using WebAssembly for that kind of performance reason. Yeah, we'll continue to be watching kind of like the edge computing side of this. Supposedly the other touted benefit is, okay, cold start times is better. But I mean, I haven't done the benchmarks, but I don't think, like, even a Docker container, if it's just an executable, like, it can't take that long to start. So there's a lot of me that wonders whether some of this is kind of like hype and marketing. But I feel like it tends to depend on kind of like the community. I think like a nice thing is, in theory, we could write not in JavaScript. But I think that benefits really mostly for the browser, because that's already the case on the back end. So I don't know. If you have different thoughts or things you know that I clearly don't, let me know. And trying to get back to here, yeah. Let's get started. I'm giving a talk on WebAssembly end of the month. I'll probably figure out what the deal is with that FFmpeg stuff. And there's maybe like 2-ish condensed videos I could do, kind of like with this knowledge that I have now kind of walked through. So that's it. Thanks for watching.